Hello GATE aspirants, welcome to part 3 of GATE Mathematical Physics series. Question 1. Identify the correct statement for the following vectors. The vectors A and B are linearly independent. So if vectors are linearly independent, so we have to find out value of this determinant first. So 3, 2, 1, 2. These are the coefficients of A bar and B bar. This comes out to be 6 minus 2, that is 4, which is not equal to 0. That means these vectors are linearly independent vectors. If it was 0, then it will be linearly dependent vectors. Then so this is option A. For option C, we have the vectors A and B are orthogonal. So let us find out A bar dot B bar. This will be 3 into 1 plus 2 into 2, and that is equal to 7, which is not equal to 0. That means they are not orthogonal. That means they are not perpendicular. And option D is vectors A and B are normalized. So let us find out their magnitude. Magnitude of A bar is under root A bar dot A bar. So that will be 3 square plus 2 square, that is 9 plus 4, so under root 13, which is not equal to 1. And magnitude of B bar is under root 1 square plus 2 square, that is under root 5, which is also not equal to 1. So these are not normalized. So option A is correct. Next, the number of independent components of the symmetric tensor Aij with indices ij, 1, 2, 3 is. So it is a symmetric tensor. So for that we have n plus 1 upon 2, and n is 3. So 3 into 4 by 2, that is 6. So option C is correct here. See, we have symmetric tensor with 2 indices. That means it is a matrix. So it will have total 9 values, and it is symmetric tensor. So that means we have values here on the diagonal, that is 1, 2, 3, and off diagonal values 4, 5, 6. And here also we will have 4, 5, 6 only. So independent tensors are this. So total are 6. And if it was antisymmetric tensor, then we will have n into n minus 1 by 2 for antisymmetric tensor. Next, the eigenvalues of the matrix are. So here eigenvalues on the, let us find out trace and its determinant. So trace of this matrix is 0. That means the addition has to be equal to 0. So only in this option addition is equal to 0. So option B is correct. Next, given f bar is equal to r bar cross b bar, where b bar is equal to b naught I cap plus j cap plus k cap is a constant vector, and r bar is the position vector, the value of integral f bar dot dr, where c is the circle of unit radius centered at the origin is. Now this integral I is equal to integral over line integral over f bar dot dr bar. By Stokes' law, we can write it as surface integral over curl of f bar into dA bar. Now f bar is equal to r bar cross b bar. So this will be equal to surface integral curl of r bar cross b bar into dA bar. So let us calculate f bar, and then we will find out its curl as well. So f bar is equal to r bar cross b bar. So that is x cap, y cap, z cap. Then r bar is x, y, z, and b bar is b naught, b naught, b naught. So we can take this b naught common. So f bar is equal to, let us take b naught common. So this will be y minus z x cap plus b naught into z minus x y cap, b naught common, x minus y z cap. So this will be f bar. Now curl of f bar is equal to curl of this. So this will be x cap, y cap, z cap. Here we have dou by dou x, dou by dou y, and dou by dou z. Then we have b naught into y minus z, b naught into z minus x, and b naught into x minus y here. Do these calculations and then you will get, this comes out to be 1 minus 1 minus 1, so it will be minus 2. So this will be finally minus 2 b naught, and in bracket we have x cap plus y cap plus z cap. Now let us find out that surface integral. So this is surface integral of this. So minus 2 b naught into we have x cap plus y cap plus z cap. Now this line integral is in xy plane. So area vector will be in z cap direction. So we can use spherical coordinates. So this will be r dr d phi into z cap. I am using polar coordinates here. So minus 2 b naught, and z cap term, only z cap term will survive. So integration of r dr d phi. Now r is taking values from 0 to 1, and phi is going from 0 to 2 pi. So this will be minus 2 b naught. Then we have r square by 2, value is going from 0 to 1, and d phi is 2 pi. So this is equal to 2 and 2 will cancel out, r is 1. So this will be minus 2 pi b naught. So your option C is correct. Next question. The value of integral e raised to 1 by z dz using the counter C of the circle with unit radius z is equal to 1. So here function is equal to e raised to 1 by z. Now we have to find singular point. So if z is equal to 0, then e raised to 1 by z, it will be e raised to 1 by 0, which is e raised to infinity. So this will go to infinity. So that is our singular point. And this e raised to 1 by z can be written as 1 plus 1 by z plus 1 by z square into 1 by 2 factorial plus 1 by z cube, 1 by 3 factorial, and so on. This is expansion of e raised to x. Now residue at z is equal to 0 is coefficient of 1 by z, and coefficient of 1 by z is 1. So integral is equal to 2 pi I, and see the circle, counter circle is z is equal to 1. So it will be at the origin circle of radius 1. So this z is equal to 0 is inside this curve. So I will be equal to 2 pi I into residue at z is equal to 0. That is 2 pi I only. So here option D is correct. So these were all the questions from GATE 2012 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.